Second lesson on polynomial functions 4.1 is going to be where we're going to graph a couple. And just remember that you have exponents that decrease, and they're going to be whole numbers. You have leading coefficient, and the leading coefficient is going to indicate which is the direction of the graph as well as the degree. So when you look at these general shapes and you look at the degree and leading coefficient, so if you have an odd exponent or degree, it's going to look like this with a positive coefficient, and it's going to reflect around about the x-axis if it's negative. And if it's an even degree, they both rise, the left and right end behavior rise to infinity, and if it's a negative leading coefficient, they're going to both fall, or go left-right behavior is going to approach infinity. So I want to look at an example to do two problems. The first one is graphing A, and in this graph, I want to know how to generally graph it. It's not a perfect graph. Each of the squares is 1. But to do this, I'm looking at the leading degree, which is negative. The leading coefficient, which is negative, and the degree, which is 3, or cubic. That tells me that the general direction of this graph, if this were a positive, it would look like this, but we're going to reflect it over the x-axis, so it is going to look like this. Left-end behavior would go to positive infinity, right-end behavior would go to, f of x would go to negative infinity. Okay, the y-intercept is where you put 0 in for x. Putting 0 in for x gives you negative 3. And the x-intercepts are going to be, usually when you factor, now how do you factor this with 4 terms? With 4 terms, I'm going to try to group them. Grouping would mean that the ratio of the coefficients would be the same. So negative 1, or just say 1 over 1, and 3 over 3. They're both equal to 1, which gives you a hint that you can group them. So to group, you have to look at the first 2 terms, pull out a common factor, which is negative x squared. And as I distribute that through, notice that I get the same thing up above it. Be careful about this negative sign here, because when you multiply these two, you get a positive. A lot of students will make that mistake and then put that as a positive there instead of negative. And I pulled out a 3 here, and now at this point I have a negative x squared of these plus 3 of these, which means that you have negative x squared plus 3 of these. These is just x minus 1. So that's how that gets factored by grouping, and I set both of those equal to 0. And I end up with 3 zeros or solutions to this graph. And in point form, I have 1, 2, 3. I took the 4 points and I put them on the graph. 1, 2, 3, and 4. Those are very close. So I then figured out that this is my main graph. I'm going to start up here and I'm going to go through those points, and I've got to end as x goes to negative infinity. Let's try a different example. Looking at this one, I'm going to see that it's like a cubic, but it's flipped and it's transferred up 4. So I'm going to, that's going to help me graph that, meaning this is my first point, 0, 4, and my next part is that it's a negative cubic, which means it's going to look like this. So I know it's got to come through here and come down like this. So what else do I know it? Well, if I set this equal to 0 and solve, what happens? 4 equals a negative x cubed. So x cubed equals 4. X is equal to the cubed root of 4. So that means that over here, somewhere, if I just say, okay, that's going to be the cubed root of 4, then I know the direction of this graph has got to go like this, come down, and look like that. Each of these are a little bit different. Notice if it were this, I would factor it by grouping. This, I would use the translation. It just depends upon what's in the givens.